Hello everyone. Today we are going to discuss about resistor. Resistor is one of the basic element in network. Network is nothing but interconnection of all the electrical elements that is termed as network. So this is one of the element. So its property exhibited by resistor is called resistance. So resistance opposes the flow of current, and symbolic representation of property exhibited by resistor is called as resistance. So resistance is denoted with symbol R. It opposes the flow of current. It is denoted with symbol R. Symbolic representation of resistor is okay. So resistor is also a two-terminal element. So you can compare resistor to a speed breaker. So whenever you're going on a road and you come across a speed breaker, you slow down your vehicle speed. So what? So why this it opposes the why this resistance opposes the flow of current? So we know that metals they have free electrons, right? So when these free electrons they move from one atom to another atom, in this movement in the process of movement they go and they collide with the atoms. So when they go and collide with the atoms, the speed of the electron is reduced, and due to the collision, heat will be produced. So this results in the reduction of current, and this property is termed as resistance, right? So if a conductor is very good, then its resistance is very less. I mean, obstruction to the flow of current will be very less. So basic term Ohm's law. So from here this term resistance came. What does Ohm's law states? At constant temperature, at constant temperature, voltage across voltage across conductor is directly proportional to the current flowing through it. So V is directly proportional to current, and when you remove this proportionality constant, you'll get V is equal to IR. So this is equation 1. And also you can write it as I as equals to V by R. See, not all, see, different metals will have different resistance. Even human bodies also have resistance. It varies. For men, it's different. For women, it is different. So this resistance, it depends upon length of the conductor as well as area of the cross-sectional of the conductor. Suppose if to length, it is directly proportional. Okay, more the length, more the resistance, and resistance is inversely proportional to the area of the cross section of the conductor. So when you combine this both and remove the proportionality constant, you will get R is equal to rho L by A. Okay. Resistance is measured in ohm after the scientists who proposed Ohm's law. Unit of resistance is ohm. Now, this rho is nothing but resistivity. Resistivity, it varies from material to material. Okay. So resistivity units, rho is, see, length of the conductor is taken in meters and area of the cross section meter square. So units of resistivity will be rho meter. Sorry, ohm meter. Now we'll calculate the power of the resistor. Okay. So power, from the basic definition, it is nothing but voltage into current. So from Ohm's law, in the place of V, from equation 1, can I write I into R into I. So it becomes I square R, or from equation 2, I'll write in the place of I'll write V by R. So it is V square by R. So what are the practical examples of resistors? Electric heater, filament bulb, electric toast. All these are the practical examples of resistors. So this power is dissipated in the form of heat. Okay, resistor dissipates heat. That is why after turning on filament bulb for a long time, and if you switch it off and if you touch the bulb, you can feel the heat. Now energy is nothing but power into time. So in the place of V power substitute VI into T, or in the place of V substitute IR by using Ohm's law, IR into I into T. So this is the heat energy, I square R T. So energy is measured in joules, power is measured in watts. So from equation 2, we got I is equal to V by R. Okay. From equation 2, I is equal to V by R. 1 by R can be written as conductance, G. It is denoted with symbol G. So conductance is nothing but reciprocal of resistance. So resistance opposes the flow of current. Conductance is the ability to allow the current to flow through the material. So a good conductor will have high conductance and low resistance. And a bad conductor will have very low conductance and very high resistance. So every conductor, whatever we are seeing, they have their own resistance. Like aluminum will have its own resistance, okay, and resistance of copper will be different from aluminum, and resistance of gold and silver. These are also metals to be different. Okay, thank you.